So standard form, it's already written, so I'll write it right there. I feel like I can do the domain in range maybe. When I see it's to the 5th power, it reminds me of a line. A line starts from the bottom, but it's negative, so it starts from the top. 1, 2, 3, 4, 5. So the domain is everything to the left, everything to the right, all real numbers. Negative infinity to positive infinity. The range is everything up and everything down, all real numbers. Negative infinity to positive infinity. End behavior as x approaches negative infinity, f of x approaches as x approaches positive infinity, f of x approaches. So let's look. On the negative side, it's going up. On the positive side, it's going down. The y-intercept from standard form is the last number. But this isn't a number, this is a number in a variable. 5, 4, 3, 2, 1, nothing. So that means the y-intercept is 0, 0. All right, I've filled in what I can. Now I need to factor so that I can get the rest and figure out the intervals. So I'm going to put this on a separate piece of paper. Negative 2x to the 5th plus 6x to the 4th minus 8x cubed plus 24x squared. I'll show you how to factor it first because I think that's the easiest thing to do for me. I notice they all have x's. I notice they all have 2 x's. So I could take out 2 x's and I'd be left with 3 left here, 2 left here, 1 left here, and none here. Okay. I could then do factor by grouping because I see 2, 6, and 8. 2 divided by 6 is 3, and 8 divided by 24 is 3. So I can see factor by grouping. So I see a negative 2x, 2 times 3, x. So 2, 2x, 2x squared. And then I'm left with negative x plus 3. And then I go negative 8x, 8 times 3, take out an 8, 8, negative x plus 3. I see a match. And then I'm left with 2x squared plus 8. Now, I want to make sure that I don't forget to bring down that x squared. The great thing is, I can solve this one right now, because if I set x squared equal to 0, even if I square root, my x equals 0, but there are 2 of them, multiplicity 2, because that's my bounce. So that's part of my answer. The bounce is just bonus. This one I can solve because it's just left with an x. Minus 3, negative x equals negative 3, divide by negative 1, x equals 3. So I have 2 here and 3 here, but I'm supposed to have 5, so I got 2 more to find. And I'm going to get 2x squared plus 8 equals 0, minus 8. 2x squared equals negative 8, divide by 2. X squared equals negative 4, square root, x equals 2i, and x equals negative 2i. So if you look, I have 1, 2, 3 reals, and 2 imaginaries. Okay. I want to also show how you can do it with the PQ. So PQ, negative 2, 6, negative 8, 24, 0, 0. Therefore, I know the only possibility is plus or minus 0 right now. So 0. This times this plus this. This times this plus, bring down the negative 2. This times this plus this. 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 Boom, 0 works. But then if you look, 0 is still the last number, so 0 is an option. Bring down the negative 2, 6, negative 8, 24, done. These double zeros tell you the multiplicity too. So now if you look at 24, my new P is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, forgot plus or minus 4, plus or minus 8, plus or minus 12, plus or minus 24. You have so many options that this is why factoring is nice. But I want you to see, if you're good at factor by grouping, This lent itself, let me zoom out a little bit, to this, negative 2x cubed plus 6x squared minus 8x plus 24. So if you saw that it was factor by grouping, you could solve the rest of the way here. If you didn't, then you're going to try numbers, which we're going to fake it because we know one of the answers is 3. So I'll try a 3. Bring down the negative 2. 3 times negative 2 plus this. 3 times this plus this. Boom. There you go. I got 3 of them. It's to the 5th power, so I have 2 left. Negative 2x squared plus 0x minus 8 is negative 2x squared minus 8 equals 0. Add 8. Divide by negative 2. Square root, and that's where you get x equals 2i and negative 2i. Okay? So all of that work, don't worry, you'll have enough space on your tests if you're doing all this work, okay, will lend itself to give you the answer in factored form. Now, if we're talking about factored form, remember, factored form is only what you can factor. This you couldn't factor. So if you look up here, factored form ended up right there. Because that was as far as you could go factoring. That was as far as you could go factoring. And that was as far as you can go factoring. These are all solving. You're not factoring anymore. So let me write that. F of x equals x squared, which is your bounce, 2x squared plus 8, and negative x plus 3. If you want to write it as 3 minus x, that's fine. My zeros, my roots, that was the 2i, the negative 2i, the 3, the 0, multiplicity 2. So I've got plus or minus 2i. I've got a 3, and I have a 0 with multiplicity 2. You have to write that as part of your answer. So therefore my x-intercepts are, you can just leave it as plus or minus 2i. You can put the comma 0 if you want, but it's imaginary, so 3 comma 0 and 0 comma 0 with multiplicity 2. I think I'm ready to graph this. This is a workout for sure. So my important numbers are 3 and 0. And if you remember when I said if the y-intercept is 0, the x-intercept is 0? So here we have this one. This is also your y-intercept. It's also going to be multiplicity 2, which means you're going to have a bounce. So, honestly, there's so many different ways that you can do this problem. Okay? So, we've pre-drew it right here. But let's pretend we didn't pre-draw it. If it's to the 5th power, it reminds you of a line. A line starts down here. But the problem is it's negative, so it starts up here. So you're going to go down. And then remember, at the 0, it's multiplicity 2, so it bounces. Okay? And then it's going to go, and then it's going to go through the 3. But if you remember, the rest is imaginary. So that means it's not going to go back up, because otherwise it would have another 0. So that is a possibility for how it could look. I would like to show you another possibility if I was to do it like that, 0. I could show the imaginary numbers there, bounce it there, and go through there. I don't care what you do. Just pick one and commit to it. With that being said, let's assume we're going to do this one because I think that's kind of more what you might do. This is negative infinity. This is positive infinity for the intervals. I'm saying this is the point, 0, 0. Remember, we can make this up. Just any number between 0 and 3. We'll say 1, 5, whatever. We're faking it. Then if I'm going to bounce here, it just has to be after the number 3. So we'll say 4, and it's down 3, or down 2, we'll say that. And then I got another one here. And as long as it's after 4, so let's say 5, and it has to be between 0 and negative 2. That's negative 1, and that's positive infinity. So if I'm going to do my intervals, it's definitely getting complex. To the 5th power is a workout. Negative infinity to 0, decrease. 0 to 1, increase. 1 to 4, decrease. 4 to 5, increase. 5 to positive infinity, decrease. Oops. Now, when it comes to the max and min, technically there is no max and min, but there's a relative max, which means there's a kind of tall point and a kind of low point. So just tell me this is the tallest point if there is no max. So you can write that there's no max, but it's technically at 1, 5. And this is your minimum, even though technically there is no minimum. That's your relative minimum. Okay? So with that being said, I probably should fix this previous problem here, because even though I said this was the max and this was the min, there technically was no max and no min. So let me write no there and no there. But if you look at this one, there is no max ever at all, and there is a definite min. Or if you look at this one, what I should have said is there is no max, but we said that was the max. There is no minimum, but we said that was the minimum. Okay? All right, let's go back to the problem. And I actually think I've answered everything I need to answer. That was a long one.